Hello there. I welcome you to this third lecture. And the topic we want to discuss is image creation and manipulation. I'm excited and I hope you are equally excited to go through this lecture with me. At the end of this lecture, it is expected that you will be able to 1. Describe color component of an image. Discuss what constitutes an image. Outline various image editing methods. Highlight various image formats for print and web. Now, once again, pay attention to these important keywords. Number 1, technology. Number 2, two-dimensional. And then 3, image. Now, an integral part of image creation is the color component of the image. In this lecture, we will discuss different types of color, the effect of color on both our mental and physical conditions. Describe the communication power of color, various color components and different messages it conveys. We'll also look into the component, format, and editing styles that an image can be subjected to. Color theory. Color is a material good of light and is used for various purposes in image design. It can be used to portray a good mood, control, attention, and make an indelible statement. Color has a significant effect on our mental, physical, and psychological view. Hence, various color or mixture of color we use in an image design can carry a lot of messages. Now, color types. Simply put, color types can be color types, can be primary, secondary, or tertiary. In the RYB or subtractive color model, the primary colors are red, yellow, and blue. The 3 secondary colors, green, orange, and purple, are created by mixing these 2 primary colors. Another 6 tertiary colors are created by mixing primary and secondary colors. Now, modeling color spaces. A color model is an abstract mathematical model describing the way colors can be represented as a tuple of numbers, typically as 3 or 4 values or color components, e.g. RGB and CMYK are color models. However, a color model with no associated mapping function to an absolute color space is a more or less arbitrary color system with little connection to the requirements of any given application. Now, let us discuss different color models in image design. RGB model. In RGB model, colors are viewed as a mixture of red, green, and blue. Light color are modeled after the 3 component colors. These 3 principal colors can be combined in various proportions by varying the light components to obtain various other colors like yellow. However, the RGB color model is also the standard way of specifying colors on a web page. In general, any color may be specified as a color name or the form. Ash, R, R, G, G, B, B. Within this color name, the R part is a hexadecimal, that is base 6. 6 number between 00 and FF. That specifies the amount of red in the color, where 00 means no red, and FF means maximum amount of red. The hue saturation light, HSL, color model. The hue, H, of a color refers to which pure color it resembles. All tints, tones, and shades of red have the same hue. Hues are described by a number that specifies the position of the corresponding pure color on the color wheel as a fraction between 0 and 1. Value O refers to red. 1/6 is yellow. 1/3 is green. The saturation X of a color describes how white the color is. A pure red is fully saturated with a saturation of 1. Tints of red have saturations less than 1, and white has a saturation of 0. The lightness L of a color describes how dark the color is. A value of O is black, with increasing lightness moving away from black. CMY model. You can use the CMY model like the HSV and RGB models to characterize any color by specifying the amount of cyan, magenta, and yellow. The three values of a color in the CMY system are the opposite of the values in the RGB system. If each value are expressed as a value between 0 and 1, the C value of a color is 1-R and also M1-G and Y1-P. These colors are sometimes called the subtractive primary colors. If you start with white light, you can filter out various amounts of cyan, yellow, and magenta to produce any color. The CMYK model. The term gamut refers to the range of colors that can be reproduced by a given process. When considering colors for display either on paper or on a display device, it is important to consider the gamut of that process. Computer monitors can usually produce brighter colors than ink on paper. Colored inks on paper act to filter out reflected colors. The next on the objective of this lecture is to discuss pixels and images. What are pixels? Pixels is the picture element that constitutes an image. An image design terminology, understanding pixels as smallest single component, picture element that make up an image or the dimensional structure that constitutes an image. Bits per pixel. Color relationship is of great importance. Now, description of bits per pixel. The number of distinct colors that can be represented by a pixel depends on the number of bits per pixel. It is the BPP. A 1 BPP image uses a 1 bit for each pixel. So each pixel can be either on or off. Each additional bit doubles the number of colors available. So a 2 BPP image can have 4 colors, and a 3 BPP image can have 8 colors. That is 1 BPP 2 raised to power 1 equals to 2 colors. That is monochrome. 2 BPP 2 raised to power 2 is equals to 4 colors. And 3 BPP 2 raised to power 3 equals to 8 colors. As 8 BPP on the other hand, 2 raised to power 8 equals to 2, 5, 6 colors. 16 BPP 2 raised to power 16 equals to 6, 5, 5, 3, 6 colors. That is high color. 24 BPP 2 raised to power 24 equals to 16, 7, 7, 7, 2, 1, 6 colors. True color. Let's look at image editing. Image editing encompasses the processes of altering images, whether they are digital, photographs, traditional, photochemical photographs, or illustrations. Traditional analog image editing is known as photo retouching, using tools such as an airbrush to modify photographs or editing illustration with a traditional art medium. Graphics software programs, which can be broadly grouped into vector graphics editors, raster graphics editors, and 3D modelers, are the primary tools with which a user can manipulate, enhance, and transform images. Various image editing methods include editing paths. Image created with pen and pencil tools is called path. A path is a sequence of straight lines, segments, and Bezier curves, which is any other image object. Many arbitrary fill and stroke properties, subpaths, and combining. A path object may contain more than one subpath. A subpath is a sequence of nodes connected to each other. Hence, if a path has more than one subpath, not all of its nodes are connected. Now, converting to path. Any shape or text object can be converted to path. This does not change the appearance of the object, but removes all capabilities specific to its type. Now, understanding image size and resolution. Know the capability to observe or measure the smallest object clearly with distinct boundaries. Understanding pixel-sized image. Resolution components. You can resize images in several ways using image design software to get the image design best result when you resize images. You need to understand the concepts behind the results on each resizing method. These concepts affect how the crop tool options operates as well. If you resize and crop images without being aware of the concept involved, you can see unexpected results. Now, creating images from print and web. Preparing images for web. When creating images for web use, keeping the file size low is very important. To achieve this format and compression level must be taken into consideration. The formats most commonly used for web images are GIF and JPG. These formats offer low file sizes and moderate to very high quality. GIF is commonly used for simple illustrations, while JPEG is more commonly used for photographs. If you are working with a photo, the JPEG file format is suggested. If it is a graphic, such as a banner, logo, or navigational tool, GIF format is suggested. Now, preparing images for print. When preparing images for print, the highest quality images are desired. The ideal file format choice for print is TIFF, followed closely by PNG. Thank you for participating in this lecture. I shall see you in the next lecture.